On this week's live stream, we discover the hidden intelligence that guides a simple AI ant. Break out the glitter and start working on your holiday parade float. Kevin will show you how. Plus, we'll meet our Scratcher of the Week and see how he's weaving COVID and other social trends into his storytelling. All this and more coming up on the Chromeworks live stream. Good morning, Internet. It's Mr. Tomec back again. And we've got another great week of really cool coding coverage and other fun content available for you this week. So stay tuned. You've already seen a little preview. I put on my science geek hat this week and really got a little too wrapped up in a little science project, which I'm going to demonstrate to you today. And it's my featured video that's going to be released at 11 o'clock this morning as well. It's not a terribly long tutorial. You'll get it wrapped up in less than 15 minutes. And it's really just me playing with this very simple code algorithm where I have these animated ants. Just one of them at first, and they're just moving across a grid, changing the color of the grid underneath them whenever they step on them. Seems simple, but there's some remarkable science that goes on behind it that I really want to talk to you guys about. So I'll be showing you that in a minute. We're also gearing up for our Santa Claus parade, and I'm going to be telling you guys today Kevin's going to be telling you today how to make your own float for our parade. This will be our second annual one. The one last Christmas was a fantastic success, and we're asking kids everywhere to make a float for us, and we'll put together the biggest possible parade we can. I'm going for miles long this year. This is what I'm looking for, so everyone get working on that. All right, let's see who's joining us here in Discord. It looks pretty slow. Deck the Decoder's here again from London, England. He's on the YouTube right now. He says he's disconnected from Discord, but he'll be joining us in a little bit. I'm also joined by Funny Animator Jim TV. Good morning, Jim.
Good morning, Mr. T. I was gonna say Happy Thanksgiving, but then I realized, you celebrate Thanksgiving 1 month earlier than us, right?
Yeah, Thanksgiving in Canada is old news already. It happens in October generally. So is today Thanksgiving? It's like Sunday, isn't it? Or what day is the actual holiday?
It's actually in a few days. It's on Thursday. So
it falls on the same day.
Early,
Okay, it falls on the same day every year, regardless of the day of the week.
It's the 4th. It's always on a Thursday.
Okay.
I think it's the 4th Thursday of November for some.
All right. All the better to have a 4-day weekend, right? All right. Well, happy Thanksgiving to all my American friends, of course, then, and best wishes to all of you. And it's Black Friday is coming up too. I'm very excited about that. I have some tech purchases I'm getting ready to make as well. That's the big event I look forward to. Okay, guys, so, I'm also joined by my co-op assistant, Andy. Good morning, Andy.
Morning, Mr. T.
So, you've been working on anything lately, Andy?
No, I was just trying to catch up on my studies, specifically physics, I guess.
Okay, yeah. Busy.
It's kind of, it's really hard to try to catch up on a lot of work recently. But I'm still trying to catch up a lot.
Yeah, It still feels a lot like a pandemic out there, doesn't it? And the things really aren't back to normal quite yet, are they, in the world?
Yeah.
Yeah. Okay, thanks, Andy. Anyway, let's get into the content here before I bore my students to tears here. So I'm going to show you guys my project that's called Langton. And I just shared it now. It's not 100% ready for publication, but I have shared it early. So I'm going to paste the URL for this project into the chat on YouTube and in Discord, and you can get it there. Or you can always find it in the file description at the bottom of the project, as always. Or at the bottom of this stream, actually, sorry. There you go. Okay, so I was watching a science broadcast a couple of weeks ago about the idea of emergence, which is how does intelligence arise or intelligent behavior arise when creatures that don't seem intelligent, like ants, work together? How can a whole bunch of not very intelligent creatures work together to create something intelligent in tandem with each other? And it's not because they're being guided by some supernatural force or whatever. It's because of math, basically. These guys, ants and other creatures like this, follow very simple algorithms, kind of like coding in the way that they move around with each other. And just by simply following a simple algorithm, when they've been programmed to build something, for example, they will build in exactly the right shape. The same with bees making honeycombs, for example. I'm not going to show you my entire video that's coming out at 11 o'clock, but I thought I'd show you the intro just to give you a sense of what I'm talking about here, and then I'll give you guys a look at the project. So let's do that right now. How do bees construct elaborate nests with thousands of symmetrical and perfectly sized honeycombs? How do ants and termites construct vast layers above and underground that have ventilation and heating control and some amazing architectural features? The answer lies in a scientific concept called emergent behavior. Today we're going to be looking at that inside a simple Scratch project and see how order can sometimes emerge from chaos. Stay tuned. Sorry about that, I was muted there. So let me reconstruct what I was just saying. Yeah, so that's a little teaser of what you guys are going to be looking at 11 o'clock today. And basically what this little short project is a demo of this prefab project that I made. So you're not going to be building it along with me, though there's lots of room to tweak and do additional work with this particular algorithm if you're interested in this subject the way I am. I'm obviously really nerding out on this topic. So this project was developed by a computer scientist by the name of Christopher Langton. He's still alive. He lives in California. And he programmed this simple algorithm where an ant will move across a grid, and depending on what kind of square he's sitting on, so the grid can be colored black or white, and depending on what color he's stepping on, it will always flip the color over to the opposite color every time the ant steps on it. When he steps on a black square, he turns left, and when he steps on a white square, he turns right. Simple enough, right? So let's run the project right now, and I'll show you guys a little bit of what that looks like in the actual going here. So I'm hitting a bunch of number buttons to get these projects going. Nothing happens when you click the green flag except for instructions. I'm going to click the 1 button now, and we're going to set our ant loose to start running around the board here. I had a pop sound going here, but I think I've removed it. So you can see my ant basically walks around flipping directions. Now you'd think it would form just a square or something, but it turns out that with this particular algorithm, he starts making an irregular kind of swirly shape after a while. It starts off very simple, and as it progresses, this swirly shape gets a little bit more complicated all the time. It takes a long time for anything interesting to happen here. So the first thing I want to do is get rid of the delays. I'm going to hit the number 2 button now, and we're going to run the same simulation, but without any delays in between the movements, so it'll go much faster. Check this out. There you go. So now my ant, now you can kind of see the swirling kind of ever-changing pattern that this ant is making as it changes the colors across the screen. Interesting. The problem here, though, is there is something really cool that's going to arise here, but it doesn't have time to run here, because by the time we get down to around 900, the thing smashes up into the wall. It's got an if loop in it that will basically stop the program when it hits the wall, because after that you're not getting valid results. There it is. So at 903 we stop. So to really see what I'm talking about, this emergent behavior that I'm talking about, we have to get into a faster version of the program with smaller graphics. So I've taken this 16 by 16 grid and I've turned it into a 4 by 4 grid. And you can get to that by hitting the number 3 on your keyboard. So I'm going to do that right now. There we go. So we've got the same thing going now, but you can see that it's swirling around on a much smaller grid, which is going to allow it to do what I want it to do. Still not fast enough though, so because I'm looking to get to 10 or 20,000 steps here. So to speed this up even further, I'm going to go into turbo mode. You can get into turbo mode by going inside your project and hitting the edit menu and selecting turn on turbo mode. Here we go. So now my ants are really motoring around, and you can see the pattern gets different all the time. And then suddenly, in just a second here, what is that? Our ant suddenly starts walking across the screen, and he builds this perfectly symmetrical highway that will keep going to infinity. And there's no real explanation for it. Scientists don't really quite get it. There's no great explanation for why this happens, but this is the kind of thing that can happen in nature as well. You get random molecules of something dropping onto of ice crystals attaching to each other, and they just happen to attach one way when they hit in one direction, another way when they hit another, and a whole bunch of random interactions later, suddenly you've got a beautiful crystal structure that asserts itself here. So this is a really weird phenomenon and fascinating one. I just can't stop running this simulation and seeing how it changes every time. Now I want to show you how this phenomenon keeps running even if you start with different circumstances. The way it's set up right now, it's always going to create the same pattern. But if you hit the number 4 button, what it'll do is create a little grid in the center of the screen of random black and white squares. That'll give our ants some obstacles to bump into, and it'll make sure that we don't get the same pattern the next time around. So let's try that. I'll hit the number 4 button, and there we go. There's a random pattern. And our ant quickly subsumes that and just starts doing his own thing. But you'll see that this time he will break out, but he'll go in a totally different direction. There he goes. Let's try that one more time. And there he goes in that direction. Let's do it one more time. So I'm just hitting the number 4. And this guy started right away. Look at that. With a bizarre set of circumstances that made him do that in turn 2000 this time. So depending on what the starting circumstances are, it might take a different amount of time for your ant to reach escape velocity here. But no matter what happens, he'll always get there, no matter what kind of weird obstacles you put in his way. Really interesting little experiment. The coding is not hard at all. Let me show that to you right now. There's a whole bunch of other stuff that I have put in here just so that I can show different modes, but the core of it is here inside this if statement. So we're just using our rubber stamp tool to stamp down these squares. My ant is actually made up of a couple of different squares, a 16 by 16 black square and a white square. And then for the later ones, you can't really see the black square, the white square here, there it is. And then a much smaller 4-pixel black square and a 4-pixel white square in there as well. And so it's just a matter of telling our ant to move around, switch to that costume, and then to stamp himself down. So if we go through the code here, you'll see that he's just repeating a loop until he touches an edge, and he's basically just moving the size of the grid, which is 16 steps. Then we're just changing a variable here that's keeping track of how many steps we've gone. And then there's this if statement here that basically controls what's going on. So it's looking at what's underneath it. If I'm on a black square, touching black, I turn left. And then I switch, I flip over to white, and I stamp that white down. And if I'm not stepping on black, it must mean I'm stepping on white, which means I turn the opposite direction, and I switch to the black, and then I stamp myself down. So a really, really simple little experiment. You could try all kinds of variations on it. I've heard that that there are ways to do it with multiple colors at the same time and watch the different ants kind of fight to color the screen by themselves. You can also shove multiple ants in here. Under the number 5, I've got a similar scenario here where 3 different ants are running around on the screen at one time. And you can bump that number up as much as you want just by changing the loop inside the code here. There's a little repeat loop. And there's actually, I made 3 clones, and I think there's 4 guys. And each one of them will individually make his own highway eventually. And that's what I think is really cool here. So they're all wandering randomly around here. And then suddenly at different times, each of them will break out. It might take a little longer depending on how they interact with each other, but eventually they always get there. I'm waiting for at least one more. Oh, there goes one more guy. He's broken free. Run away, little ant. And it might take a while. There's a third escapee there. And the 4th one might not get around to it. We might need a bigger screen. Yeah, this guy bashed into a wall and stopped. So we had 3 escapees there, which is kind of interesting. Anyway, so this is a really fascinating little branch of computer science, and it's where computers intersect with biology, and I think that's so totally neat. Anyone in Discord or on the chat have what's happening in the chat here? Wow, this is cool. Reminds me of John Conway's Game of Life. I'm not familiar with that deck. Does anyone else on the Discord know what he's talking about?
I think actually someone made a simulator of that on Scratch. If you want to search it up, Game of Life. It's got a grid, and it's you can change the square, like the squares change color depending on their neighboring squares.
Really? Okay.
And you can make really cool patterns and stuff.
So just type Game of Life.
Try searching it out.
Game of Life. Let's see what comes up. Conway's Game of Life. Here it is. Yeah. All right, let's run this project. I was not aware of this one. Wow, thanks for that suggestion, Deck. So let's have a look here. So, anyone have any idea what's going on here, or should I read the instructions?
I think the squares are changing color depending on their neighboring squares, but if you read the instructions, maybe there's something.
Let's read the instructions here. It's Game of Life Cellular. Let me zoom in on this here. Can someone mute over there? Game of Life Cellular Automaton devised by John Conway. As far as I know, the first 480 by 360 cell grid, and probably the fastest implementation on Scratch. So there's some buttons, 1 to 4 to select a built-in life form for creation, 5 to select imported custom life form, T for toggle the grid size, and I, okay. So we have to insert some creatures into this, I guess, by hitting the 1 to 4 button. Yeah, I don't have time to read the whole thing here right now, but that seems like a good starting point anyway. So let's max this out here, and I'll hit the number 1 and click. I'll hit the number 2, a pulsar, and click that. And a number 3, a pentomino. And so these guys all grow in different ways. I wonder what happened to
try placing them next to each other, something
like so that they interact with each other.
Oh, there, did you see that?
Yeah.
They crashed into each other.
So I'm making this pentomino crash into another thing. Let's just seed a bunch of these down here. Oh, they're all different colors. And let's do number 3 here. So this is just a much more elaborate implementation of this. So the custom, I guess you have to import your own sprite to get a custom one in here. I'm not quite sure how that would work. Huh. Anyway, so a much more elaborate implementation of what I'm talking about here. So I guess the question is what eventually asserts itself after the thing's allowed to interact with itself this way. It does look a lot like cells under a microscope, doesn't it? Very cool little experiment. Thanks for pointing that out, Deck. That was really great. Deck has sent me a link to a Wikipedia article on Conway's work here, so let me just quickly call that up. Hi to A&W Adventures, by the way. Let me switch over to that. The Game of Life is a cellular automaton devised by the British mathematician John Horton Conway in 1970. It's a zero-player game, meaning that its evolution is determined by its initial state, requiring no further input. One interacts with the game by creating an initial configuration and observing how it evolves. Okay, well, this version actually is interactable, and that's the miracle of computers, isn't it? So the All right, so there's a bunch of rules that these guys are following, just like in my ant simulation. Any live cell with fewer than 2 live neighbors dies, as if by underpopulation. Any live cell with 2 or 3 live neighbors lives on to the next generation. Any live cell with more than 3 neighbors dies by overpopulation. And any dead cell with exactly 3 live neighbors becomes a live cell, as if it's reproducing. Anyway, and so I'd have to do a little more reading on this, and we don't have time to do that in the scope of this show. But really interesting topic for you guys to look into. I made this project also as an example to you guys of the kind of stuff that you can do as a science project, right? So I've dressed up this Scratch project so that when you click the green flag, a little description comes on the screen of what this Langton's ant experiment is all about. And you can see that I've got some cards here. This alone would be enough to get you a really good grade in a science fair or a science project for school. Now, I'm not suggesting that you guys steal my work here, but you can really you can find really interesting little principles inside Scratch, or just use Scratch to illustrate what's happening in another scientific principle. You could do something on hibernation, for example, and just have a bunch of appearing graphics and cards, and maybe even make a bear fall asleep when you click on it or whatever, or just have a giant clock running 365 days a year and watch what cycle a bear is in as it goes through its hibernation cycle. I'm just kind of riffing off this off the top of my head, but you can see how Scratch is a really fantastic tool for putting school projects together. And I'm going to continue to pitch that to you guys. Wow, I've got this music still going in the background here. Let me turn that off. Oh, that was getting a little annoying there. I have some custom music for this project as well, which is really cool. It's kind of an ominous ooh sound. Anyway, I wanted to talk to you about one other thing that I learned from this project, and this is probably going to be obvious to some of you guys who've been scratching for a long time, but it wasn't obvious to me. I was trying to figure out how to draw a 16 by 16 pixel grid inside Scratch, and how to be precise like that. Every once in a while, you have to be scientifically precise when you're doing stuff in Scratch. The solution I came up with was to design my square in Photoshop and then import it as a costume into Scratch. But when I imported it in, I noticed that these squares in the program are actually conformed to real sizes in pixels if you zoom far enough. So this is pretty much as close as you can get inside your grid here. And you can see that this particular square, I'm going to convert to vector mode here so I can move it around, perfectly fits into one of these squares. So these squares, it turns out, represent 2 pixels on the screen. Not 1, but 2 pixels. So if you wanted to draw a 4 by 4 object, you'd have to just divide the number of squares by 2. So now this is a 4 by 4 square. And if you were going to, as I wanted to create a 16 by 16 grid, you can just simply drag it out so that it's perfectly conforming to these squares. I don't know. Did you guys know that? I just wasn't aware of how the grid system worked, and maybe I just never looked into it. So let me know in the chat if you've actually learned something. A&W Adventures, he's going to sleep? Okay. As I remember, A&W is far away from here, so thanks for tuning in at bedtime. And nice to see you again. All right, so yeah, I don't know if any of you guys actually knew this particular facet of Scratch, that you can draw precise squares by using the grid, the underlying grid. So the weird thing that comes out of this, though, is that you can get squares here. The smallest unit in Scratch is actually 1/4 of one of these squares. So if I grab a paintbrush here, for example, and bring its size down to 1 point, what I'm actually going to, let's go to bitmap mode where it'll turn into a square. Let me drag this down to 1 point. You can see that the grid here is actually small enough to fit 8 of these guys. So actually, I'm trying to remember if this is actually 4 pixels, rather, because each one of these I realized is half a pixel. Yeah, so each of these squares is actually, I think, 4 pixels. Let's confirm that again, because I'm getting confused now. So I'm going to upload a costume here, and this is how I actually figured this out, right? I just went in and grabbed a 16 pixel square that I made in Photoshop, imported it into here, and then noticed how many squares it takes up. And yes, it takes up 4 squares. So I was wrong. It's actually 4 pixels per square on this grid. And so you've got to divide everything by 4. But because you can draw 8, you can actually draw a half pixel in Scratch. And I'm not quite sure how that works. But that's an interesting little thing that I've just discovered. All right, so let's move on. I've got lots and lots of great content. My co-op crew was working overtime producing some stuff for me this week, and I wanted to start with the Christmas special. Those of you guys who've been members for quite a while will remember that last Christmas, the Friday before Christmas, we put together a fantastic holiday special with all kinds of special Christmas themed Scratch projects and an art demo, and it all came to a head at the end with our Christmas parade. And this is a chance for the whole community to get involved, and I'm hoping classrooms around Ottawa and beyond will want to contribute their own work as well. And the idea is just, I've created a template for you guys, which you can very easily modify, and here it is right here, which you can very easily modify and turn into your own parade float. Then you just save it into a studio. I pick it up, put it all into my own project, and run them one after another into a gigantic parade. Now, I asked Kevin to put together a little how-to article on how to do this, and this is him right now.
Everyone loves a Santa Claus parade, and today I'm going to show you how you can join ours. Chromeworks is holding its second annual holiday parade on December 18 at 10 a.m. My name is Kevin, and today I'm going to show you how you can build and animate your own parade float and enter it in our virtual parade. First, open Scratch and search up Scratch Holiday Parade. Then, click on Studios, and you should be able to recognize our Holiday Parade studio by this thumbnail. If you're having trouble finding it, you can go to this URL or click the link in the file description. The studio or link should be able to take you to this page. After that, click on the link that's on the left side, which will take you to a project made by Mr. T called Scratch Holiday Parade Template. Click Remix and voila, now you can start making your own animated parade float. First, type in your name or your Scratch username here, and give your parade float a name of your choice. Then, go to Costumes and design a parade float of your own. To animate your parade float, you'll have to create a short series of frame animations. A frame animation is a type of animation created by playing a series of drawings or pictures at a fast pace. Now that might all sound a bit difficult to do, but don't worry, we'll make sure that you get the hang of it for this tutorial. First, make sure that you've designed something in the first costume. Then, copy and paste the first costume into the second one like so. After that, move your character's arms or objects a little towards any direction you'd like. Then repeat the same steps for the next 2 costumes. Try to make the movement directions opposite from each other in each costume. Now that you've finished making an animated parade float of your own, it's time to get your design showcased on the Chromeworks Christmas Holiday Special. A reminder to click share after you've finished creating your parade float. First, go back to the studio called Scratch Holiday Parade, the studio where you found the link to the parade float template. Then, copy and paste the link to your animate parade float into the Add Project bar and click Add by URL. You could also click Browse Projects and add your animated parade float that way. Congratulations! Now you have your own animated parade float that will be showcased on the Chromeworks Christmas Holiday Special. That's it for today's animated parade float tutorial, and I remind you that the parade will be hosted on December 18 at 10 a.m. If you're worried about forgetting the time and date of the parade, be sure to subscribe to Mr. T's YouTube channel and ring the notification bell.
Ho ho ho!
Well, I just thought that was a delightful little segment. Kevin is really coming along in his video editing. You guys probably don't remember his first couple of efforts about a month and a half or so ago when he started with us. But every single video that he produces is just getting more professional and getting more fantastic. So congratulations to Kevin on doing a really great job with that. Yeah, so please enter my contest. I'm going to leave some links in the description down below for where you can get to that template and how to get to my studio where you can share your parade floats as well. We've still got quite a bit of lead time here, but I really want to do a big parade this year. So I'm asking everyone in the Scratch community to share this info and let's get it distributed far and wide so we can get lots and lots of floats in our parade this year. All right, so it's time for our Scratcher of the Week. And this week's Scratcher of the Week is Sterlon, a really famous Scratcher who is, again, a digital storyteller. He tells some great Stickman animation stories, and my man Aiden's going to talk about it right now.
This episode on Scratcher of the Week, we're going to be talking about a Scratcher named Sterlon. He makes funny and relatable animations about everyday life and some current events like COVID. This clip here of one of Sterlon's animations will give you a great little taste on what he makes.
Wait, where is it? Could it be in the sink? No, it isn't in the sink. Where could it be? I've looked everywhere. Oh, it was in my pocket the entire time.
So, taking a look at Sterlon's profile on Scratchstocks.com, we can see that he's number 19 in the world for most followed and first in San Marino. We can see his San Marino ranks, his global ranks, and his total project stats, and we can see some of his most popular projects. We can see that he talks about COVID, having low battery on your cell phone, and other relatable funny things. Here's another example of a super common situation that Sterlon animates. In the clip, the character is trying to find a charger from the bottom of the bag, but pulls out some super over-the-top and funny things.
Sterlon, do you know where the charger is?
I think it's around the bottom. You just gotta take some stuff out.
Okay. Okay, he sure does have a lot of stuff in here. Why does he have this in here? What was he planning to do with this? Oh, no way. Is this a whole table in here? Hey, Sterlon, how did you even fit this in your backpack?
But he does much more than make animations about iPhones. He also talks about a pretty serious subject, coronavirus, and tries to make light of it.
Totally normal day. 2020 has been such a great year lately. I wonder what's gonna happen next. Let's check my phone to see what's on the news today.
It is 2 hours past lunch. Get up!
No.
Sterlon's animation here is also about the coronavirus lockdowns, but what he does especially well is really exaggerate some of the problems that people are going through and kind of make them even funny. A great example of this is when the character goes all the way down to school to find out that the schools are closed. Even though this probably didn't happen for most of you, it's still a really fun and lighthearted way to bring light to the situation.
Dang it, I got ready for nothing. Well, at least I don't have to go to school.
That'll do it for this episode of Scratcher of the Week. If you want to check out more of Sterlon's projects, you can check them out with the link on the screen, and have a great day. Thanks.
Thanks a lot for that, Aiden. Yeah, I've been looking at Sterlon's work, and he's done some really fantastic stuff. No wonder he's so popular. So we've got 36 projects shared here. He does some really fun thumbnails, as you can see, and there's some really awesome projects here. I've got one more queued up here. I think it's... Oh, what happened to it? No, I thought I had one of his projects queued up here. Oh, this one's called Amateur Life Hacking. And I didn't really want to play this at length here, but I just wanted to show you guys some of the cool things that I really like about Sterlon's work. Check out the really smooth transitions that he does here when I click the green flag. How, yeah, it kind of transitions and then zooms in. He's doing camera work inside this, and I think that's a really cool aspect of this. Like, normally when you're looking at these videos, particularly from amateur filmmakers, the backgrounds are often really static, and you have stuff moving in the foreground and changing size and changing shape. But this looks and feels a lot more to me like an actual movie where there's cameras moving around, zooming, and doing transitions and stuff like that. I think it's a really sophisticated little bit of filmmaking here. Let's watch just a couple seconds more while we're at it. Oh, not very loud.
Do you ever just accidentally crack your phone?
So one other thing, so we're about to segue into a different segment here, but this kind of reminds me of what we're about to do. So our story of the week is Your Fles. Another famous scratcher has done a project called Comments or Comments 2, and the idea is that he's taking screenshots like this of comments that he's gotten from the Scratch community, just requests of what people have asked for him to put into videos, and he's basically done everything that his user community asked him to do, no matter how ridiculous. It's a really fun little sketch, and it forms the basis of our Story Corner this week. So let's turn now to Kevin's Story Corner segment, where every week he takes a look at a digital story in Scratch and then peeks under the hood to see an element of how it was coded or developed. So let's go to that right now.
Hi everyone, welcome back to Story Corner. My name is Kevin, and today we're going to take a look at a short animation called Comment Animations 2, made by a scratcher called Your Fles. Let's dive right into it.
The theory of the... Wait a minute, is that a pumpkin?
I'm very hungry.
Yes, it's finally over. I can rest now.
What struck me as interesting about this project was this custom block that the scratcher had used in this animation. If you take a look at the costume section of this project, you'll realize that this is a frame animation. A frame animation is where the animator will create tons of similar drawings or pictures and play them at a fast pace to create an animation or video effect. As you can see, this custom block defines a function that will repeatedly switch costumes at a given speed until it gets to a specific costume number. The speed number here controls how fast the animation will run or the speed of the changing costumes. You can make the animation run faster by decreasing the number or making it run slower by doing the opposite. The costume number here controls when the functions or blocks will stop running. This is a very useful custom block for scratchers that like creating frame animations. By using this custom block, Scratch frame animators can save a lot of time on the coding process of their animation. The logic and concept of this animation is also pretty popular these days. Lots of Scratch animators are also creating different variations of comment animations, and some of them are also using this custom block in their animation. A reminder that this custom block works best and saves the most time with frame animations. That's it for today's Story Corner. I remind you to keep scratching. If you like this video, don't forget to give it a thumbs up and hit the subscribe button for more awesome Story Corner videos.
Thanks again to Kevin, who had a really fantastic week and produced a ton of content for me. So I'm really grateful for the hard work of all my co-op students. If you're interested in doing some co-op for Chromeworks, by the way, I'm always looking for new students for the next semester. If you're engaged in any high school co-op program anywhere in the world, I'm pretty sure I'm able to host you in a virtual co-op. Talk to your teacher about it, because I can turn you into a content creator and give you co-op high school credits for working for my YouTube channel. What a fantastic idea. It's mine, of course. Anyway, so please reach out to me if you're interested in doing a co-op placement. I'm looking for video editors, and I'd also be happy to take on a web designer, graphic designers, and basically anyone who's interested in creating and editing content for a busy and growing YouTube channel. All right, guys, so one last segment for you to do. Abraham is back with a game review. He does a game review for me every week, and this week he's done a really awesome 3D game. A few weeks ago we were looking at Funny Animator Jim's early concepts for a 3D game, and I'm just fascinated by this technology, and someday I'm going to wrap my head around the math and try to make one of these games myself. But for now, let's show you a really popular 3D game called Crystal Hunter, I think. All right, here it comes now.
Hello everybody, today we'll be reviewing Crystal Seeker 3D by GGNEJ, and without further ado, let's dive right into it. The controls of Crystal Seeker 3D is very basic, consisting of W, A, S, and D keys to move the character, along with the arrow keys to move the camera. I very much enjoy jumping on enemies as if I were Mario stomping on Goombas. Crystal Seeker 3D is very reminiscent of old 3D platformers such as Ratchet & Clank 2002. When you fall off the map, the camera zooms in on you and plays a falling whistle sound effect. There are 9 levels in total in this game, with the last level being a boss fight. This is however so the first level, because it is quite long. I thought I would have fallen out of the map here, but the yellow block has saved my life. I was under the impression that you could fall through these logs, but they turned out to be just ordinary bridges. We are now nearing the end of the game, and when I make contact with the object at the top, level 1 will be finished. This game is not very complex and very beginner friendly. I would definitely recommend this to anyone new to video gaming or is just interested in Scratch games. If you enjoyed this game review, please like and subscribe, and I'll see you next time.
Well, thank you for that, Abraham. That is a really cool looking game. I actually have it up here on my screen. I should have switched over to my other screen. So let's go to that right now. So a few weeks ago we were looking at fake 3D, but this is the real thing, and you can see as we're playing it. Well, let's just carry on here. We'll go fast. So this game is optimized up the yin-yang here, like set up for if you're running it on mobile, on a slow computer, on a fast computer. It doesn't even matter. There's just there's a different variation of it for no matter what scenario you have here. Though the writer does suggest you to run this in Turbo Warp, which will convert it to kind of a fast Java version that runs much, much faster. So you move with WASD, and you rotate with your arrow keys, and you can see this is real 3D. You can see that that no matter where we move here, like if you look at the sign, for example, as we spin around it, we're really seeing different variations of it as we go along here. There's probably, I'm suspecting there's very few actual sprites in here. They're mostly just, this is all mostly done with math, I would imagine. Let's have a look at the code for a second. Yeah.
There is. Did you see the enemies? It's using kind of a combination. Like most of it is this the pen stuff, right?
Mm-hmm.
But if you go a little further, there's those enemies. Actually, you can see one in the distance right now.
Yeah, let's
So
do
if
that
you
right
go,
now. What? Have you played this game before, Jim?
yeah, I have. I just haven't completed it, but there's a full walkthrough on YouTube, and it took them an hour to complete the whole thing.
Okay, well that's pretty impressive for a Scratch game, I guess, eh? No, if you play a Scratch game for more than 5 minutes, it's usually an accomplishment. So yeah, here's one of our enemies.
Yes.
And yeah, he is two-dimensional, eh? No matter which direction you look at him from, you're seeing the front. So he's an actual sprite then, I guess. Oh, there he is. He's coming for me. And you just have to avoid him. Jump on top to vanquish it. Okay, it's just like Mario, right? There we go. I got rid of him. Anyway, a really cool little game. I'm just so impressed with the math behind this. And the code, as you can see, is off the charts. I just want to see how much code there is in the main block here. 374, is that it? Oh, I thought there was more code than that to it. And draw 3D here looks like it's one of the major sprites here as well. I'm going to click on that. Is this where all the action is happening? It sure looks like there's a lot of math in here. Let's see how many blocks. Yeah, 2,373 blocks. That's what I was looking for. This is where the real guts of the 3D is. And as you can see, if you don't have university level math diploma here, I don't think you're really going to understand what's going on here. Even zooming in on the wow, my mouse is just completely frozen here. I'm going to hit the stop button because this thing is just glitching out my computer. Whoa. My mouse has actually gone crazy here. Okay, stop. Wow. I think this game is so complex it actually glitched out my computer. All right, let's see if we can get this stopped now. And the music is still going, and I'm back in Photoshop now, strangely enough. Yeah, it looks like it booted me right out of the Chrome web browser. No big deal, though. You can see what I was working on
Dismiss
before.
task switching window.
What? Okay, I don't know how that happened. Anyway, so that's a really cool 3D project with a frightening level of complexity to it. So, as you can see, 3D modeling is not for the faint of heart, guys. And this is something that is probably done. I'm thinking if you're going to spend this much time putting something together in Scratch in 3 dimensions, it's a cool kind of proof of concept. But really, you should be moving on to Unity, like my son Jeffrey did, and start making 3D games there, because that's the real environment where this is going to happen, and you're going to be able to do it without crushing your computer and putting too much of a workload on everyone else. I'm impressed to see it. I can't hear Mr. T. Oh, I'm hoping the audio is still working on the YouTube. Can you hear me on YouTube, guys? Oh, actually, I don't even have my browser running. I can't see my YouTube feed here anymore. Okay. Yes, can hear you now. Okay, good. All right, so I'm still audible anyway. All right, so you know what? I'm pretty much out of content here anyway. I've just wanted to give you a quick look at this 3D game and have a little conversation about it. It looks like my computer is rapidly dying on me. I think I have too many apps open here. I got my video editor and Photoshop, and I had about 20 Chrome tabs open on 3 different screens. And now I'm paying the price for it. So that sounds like the universe telling me that I should probably quit for the day. So I'm going to take off now. A reminder to please enter our Christmas parade contest and design a parade float for me. You'll find the details in the description. And I'll be back next week. I'm very excited. Next week I am going to be bringing you an interview with Paddler Games, famous scratcher who is another digital storyteller. I've gotten in touch with him lately, and we've been speaking in real life. So I've already done that interview. I'm just editing it and putting it together, and it'll be ready to go next week. So can't wait to bring that to you guys. In the meantime, we will